Hello, everyone. Good morning, good afternoon, or good evening, depending on your time zone. Great to have you in our YouTube stream. And today we continue the SAP Cloud Lifecycle Management Webcast Series. Today we will talk about downtime-optimized conversion to SAP S/4HANA. Our expert for today is Boris Rubart, who is product manager in cloud and lifecycle management at SAP. My name is Larissa Brinkman from the SAP Global User Groups organization, and I'm your host for today. We kindly ask you to place your questions via live chat, and we will answer them at the end of the presentation. The PDF of this session will be available for download in the video description under the same link. With this, I wish you great interaction and kindly ask Boris to take over.
Thank you very much, Larissa, and a warm welcome from my side as well. You have heard my name is Boris. I work as a product manager, mainly on the software update manager, the technical tool for the system conversion, and on system conversion topics overall. Today we have the topic of downtime-optimized conversion to SAP S/4HANA, a special approach that promises to reduce the downtime of that approach. And there are some prerequisites to be considered. So this session will provide the overview, the prerequisites, potential limitations. That is what we have. For the duration of the session, I will mute my video, but will be back later then. So let us have a look. This is one of those sessions that are part of the SAP Cloud and Lifecycle Management Webcast Series. You see the URL where you find all the sessions, and you'll find the presentations and recordings from the previous sessions as well. As a part of this Cloud and Lifecycle Management webcast, I have listed those sessions that are mainly related to the Software Update Manager and to conversion topics. So we have had an overview about the SUM tool, the Software Update Manager, on the migration case, on various downtime optimization approaches where downtime optimized conversion was already mentioned. We had an overview on the task that the Software Update Manager executes during the system conversion. Then we had a session specifically for the target SAP S/4HANA Cloud Private Edition, and now we are about downtime optimized conversion to SAP S/4HANA. The dates listed here are the current ones, so you should consider to check the web page to find the latest dates in case there's any change. Okay, so in a nutshell, as an overview slide, one slide you can say, what is downtime optimized conversion? It is it is an approach that reduces the technical downtime of the system conversion to SAP S/4HANA. So the scenario is obviously system conversion from ERP 6.0 to SAP S/4HANA. And you already know that the system conversion is one possible transition scenario out of three. We have the new implementation, the system conversion, and selective data transition. System conversion will take one ERP source system and will convert the complete system to SAP S/4HANA. And when we talk about SAP S/4HANA, it is the on-premise version. The benefit of this approach is that we have a relevant downtime reduction, and we will see later why I call this relevant. The approach as such is moving activities from downtime to uptime, at least partially, especially the data conversion. So we will talk about what data conversion is in the context of a system conversion. If migration is part of the activities of the Software Update Manager, those will be partially migrated to, partially moved to uptime as well. The approach is generally available for educated consultants. That means if you would like to use it, we have a classroom training, 2 days offered by SAP Education, an assessment. And if you pass the assessment, you can use this approach, as it is required to request a password to really execute the scenario in the software update manager. This and more aspects are listed on this portal page, so SAP support portal page. You see it's in the software logistics area. We have a page on the software update manager, and there's a separate page on downtime optimized conversion approach that holds various aspects and details on this. So that is the general overview. The session as such is structured along 3 sections: the overview, project considerations, and then a sequence of architectural process steps where I would like to pick out some of the steps, but the others are available for you in the PDF that is provided as usual. So the overview, we start with the standard approach, a recap of the major blockers of the processing. You see that we have a green uptime processing by the software update manager. This is of course much longer than shown here. That will be several days. The software update manager will already reduce the downtime by using what we call the shadow system approach. Shadow repository has been created in uptime. Then we have the move to downtime, where the software update manager has technical downtime, where migration is executed if required. That means if the source system is not yet on SAP HANA database, the software update manager will execute the database migration. Then we have the title of update, so applying new software components or update existing components and doing some data conversions if required. Data conversion are split here between the software update manager and activities that are to be executed after the software update manager. Now, data conversion as a part of the system conversion overall. The data conversion means SAP S/4HANA as the target product version has a new data model, has new tables, and that means that during the procedure, the table content from the from the old tables have to be transitioned to the new tables. And new tables, famous examples are AC.A, the Universal Journal. The conversion, the transition of the table content is executed here in this step after the software update manager. And there are other tables like MATDoc, where the software update manager will execute this conversion. So partially by the software update manager, partially afterwards. What does afterwards mean? As soon as the software update manager is finished, has executed its own tasks as some downtime, there are some post activities, and then the ABAP system is running, but the SAP S/4HANA system is not yet available for end users, since the colleagues from the financial area, for example, have to execute this fin and material ledger data conversion. Those are IMG activities. So the experts start the IMG implementation guide. They do the fin customizing. In this intermediate step, the fin customizing for SAP S/4HANA can be executed as a preparation for the actual data migration then, and some post activities. So these are a list of activities to be executed, and then business validation and ramp up. Then the system is a real full SAP S/4HANA system and available for end users. Again, we see different parts of downtime. We have to be specific when we talk about downtime. Which aspect are we focusing on? We see the technical some downtime that is related to the tasks of the software update manager. The overall technical downtime is longer, since there are some data migration activities that are downtime. Downtime in the sense of the system is not available for end users. And in your project, you will most probably consider the overall business downtime. So from ramp down until ramp up of the system. So including also those activities that we from SAP cannot directly influence with our tools, like business validation, regression tests. That's up to your project. That is the standard approach. So in here, we do not see yet anything about downtime optimized conversion, but this will be illustrated later. Next step is, what kind of possible approaches do we have for the system conversion? Obviously, we have a standard approach. That's what the title says. Now, the next slide is stating there are 3 main approaches. We will discuss this in more details later. We have the standard approach that we had a look at the major blockers. Of course, this standard approach allows optimization, downtime reduction as well. So it's possible to tune the number of processes, especially R3 load processes. You can consider archiving to reduce the source database size, things like that. And the tool as such is improved step by step. Typically, we have 3 times a year a new SP version of the tool, which may include optimizations as well. The second approach is the one that I talk about today, Downtime-Optimized Conversion approach. It is an option of the Software Update Manager, so it's inbuilt. It can be switched on. It can be used if you have done the education part, and it will move data conversion partially to uptime, which will be elaborated on later. And the third approach that is listed here is not approach of the Software Update Manager, not approach that you as a customer or partner can use. It's an SAP offering, It's called Near Zero Downtime Technology, abbreviated as NZDT. And this is a service offering that SAP experts are offering to reduce the downtime. The general, very rough statement is, from standard via downtime optimized conversion to NZDT, the downtime will drastically be reduced, especially with NZDT, but the effort is higher as well. So it does not come for free. Obviously, a consulting service must be paid, but you will also have to consider hardware costs. Now, in the middle, downtime optimized conversion, that's an approach that educated consultants out there at the customer or from a partner can do on their own as well if they are educated. So no costs on for a consulting service of SAP. Still, you have more effort because you need more preparation, more testing, more test runs especially. And we will see later why this is the case. In general, we recommend the migration planning workshop from SAP to evaluate what would be an appropriate approach for your conversion project. There are additional aspects to be considered, as mentioned in the session on various downtime optimization approaches of the Software Update Manager. So we have the technical downtime optimization app in the SAP Support Launchpad, and we have a dedicated tile in the SAP Readiness Check on downtime estimation. Now, the downtime optimized conversion approach in comparison to the standard approach. We have seen that the Software Update Manager has duties, has tasks to execute, and there is conversion afterwards as well. And now the downtime optimized conversion approach will move to uptime processing is the data conversion mainly. So the task to move the content from the old tables to the new tables of the new SAP S/4HANA data model. And if migration is required, so if source is not yet on SAP HANA database, then also the migration part will be moved to uptime processing. And now the tricky part is that the downtime optimized conversion approach of the Software Update Manager will also execute those data conversion activities that in the standard approach are not executed at all by the Software Update Manager. So downtime optimized conversion approach will also move those fin data conversion activities partially to uptime to reduce the overall downtime. Now, why do I always say partly? Well, if we execute those activities in uptime while end users are still working on the system. For example, we migrate table content from source to target HANA database. Then after that migration, it could be that end users are doing changes on the database that change those tables there. And those changes are reflected by the tool. There's a record and replay technology built into the Software Update Manager, and the tool will take care for this. So that's why there is typically a partial data conversion, migration, and uptime, and in downtime, the remaining data, the delta created by end users, will have to be considered and will have to be handled by the tool. So table conversion is moved to uptime processing as discussed, MUTDoc as one example, and ACDoc-A even, partially in uptime. Then there are some specific parts where not a complete table is moved to a different table, but only fields, specific fields of existing tables are adapted, especially conv and VBFA. This can be executed in uptime as well, since those large tables take time to be adapted. And as mentioned, migration, if source is not yet HANA, then the database migration of those tables affected by the new data model is moved to uptime processing. And in addition, I may manually select large application tables that are not anyhow considered by the tool and say, well, these are not undergoing a data conversion. Nevertheless, there's a large table. I would like to select this table to be migrated in uptime as well, including data processing at the beginning of downtime. That is the concept of downtime-optimized conversion approach. And that is the essential information on how this approach is working. And now you see it's magic. It works pretty well, and you may leave the session, but stay with us. There are some more details on how exactly this works, and especially the question, well, what do I pay for it? There must be additional effort, which is indeed the case. So let's dig into a more detailed discussion and comparison of the approaches. Again, this is the overview that we have seen before, the standard conversion with uptime processing, with downtime of software update manager, of fin and data conversion. Now, on the slide later on the bottom line, you will find downtime optimized conversion, similar to the picture we just had. It's just there could be two additional approaches in the middle. So that is a more comprehensive overview now. The next approach that is introduced here is downtime-optimized DMO, also known as uptime migration. So this specific migration approach, downtime-optimized DMO, is only selectable, is only supported, is only possible if the source is not yet on SAP HANA database, because only then we have the migration case. And then we may say, well, downtime optimized DMO that is not restricted to system conversion can nevertheless also be used for a system conversion. That means we reduce this migration part of the software update manager by manually selecting large application tables, telling the tool those tables shall be migrated in uptime already. Same story, uptime means end users are working on the system. So the tool will do some delta migration to reflect the changes of the end users. And even in this delta phase, there could be additional changes by the end users. So at the downtime begin, there is the delta migration of the remaining delta and the remaining tables that have not yet been migrated in uptime. That is a possible approach to reduce the downtime. The fin data conversion is not touched, as this approach is only focusing on migration. And we have a downtime reduction that you may see here. There is a reduction that could, for some projects, be enough to say, well, we have tested it, and this will allow us to run the overall downtime in a period, in a time that is sufficient for our project. Again, only if the source is not yet HANA, but if the source is already on HANA, so ECC on HANA, sometimes referred to Suite on HANA, then there is another approach that is called near zero downtime maintenance, only for source on HANA database. For this approach in general, we can say the activities of the software update manager are anyhow only two, as there is no migration case. The other activities are the same. And in here, it's that the update part is partially executed in uptime. So the update part is executed in uptime. That should be, for example, table import. So specific customizing tables where SAP is delivering content will already be conducted in uptime, with the same concept of end user activities are considered with the data. That is also some downtime reduction, and that's available. You even do not have to run through a classroom training for that. It's available. It's possible to be used for system conversions. But the big one is the downtime optimized conversion. We have seen this picture before. The tool will, if required, execute migration and uptime, but also data conversion, especially also the fin data conversion, that in the other approaches are activities after the software update manager. But in here, for downtime optimized conversion, there is no fin or material ledger data conversion after software update manager. It's all covered by the tool. And so there we have a drastic reduction. Again, it comes with higher effort, so it has to be evaluated whether the effort it's worth to have additional testing and some restrictions that are to be discussed. I told you that those approaches are available with a software update manager. Where do I find this? Well, in one of the first dialogues, you will get the respective entry. So the dialog offerings of the software update manager. If the source is not yet on HANA database, then this dialog, I think it's the third or fourth dialog of the software update manager, allows you to decide on the scenario strategy. There you can keep the default, which is the standard conversion, or for source on non-HANA, you may choose downtime optimized. That will be either uptime migration for only migration reduction, or the full-blown downtime optimized conversion approach. If the source is already on HANA database, then it looks similar. It's just that there is no uptime migration or downtime optimized DMO, but there instead near zero downtime maintenance is offered. And you see these little icons there. If you move the mouse over the icons, you see the explanation for these approaches that you may choose. But hopefully I have already explained this, that you have a general understanding of those approaches. By the way, short side remark, in this dialogue on the scenario strategy, you may as well use the prerequisite check tool. The prerequisite check extended tool is offered here as well. So that's another good idea to consider this. But this is not related in particular to downtime optimized conversion. Last part here is that for downtime optimized conversion, there is meanwhile even an additional possibility to reduce the downtime, and that is to select long-running XCLAs and to move those execution from downtime to uptime. That is possible independent on whether or not the source is already on HANA database. Now the question is, what's an XCLA? An XCLA is similar to an XPRA. Not sure if that helps. That is one of the activities that do those conversion parts. Let's put it like this. There's a more modern version of XPRAs. They are called XCLAs, and they are executed by the software update manager, similar to XPRAs. And now you may select a specific XCLAs to be executed in uptime by the software update manager, and this slide shows the approach. You do a copy of the productive system, you have a sandbox then, and you do a system conversion run on the sandbox, which will in downtime also cover, of course, the XPRA and XCLA execution. The approach is supported for target SAP S/4HANA 2020 and higher, of course, also with the available higher versions. After you have done the run, the tool will provide a metadata file, an XML document, which contains the metadata and especially the execution runtimes of all those XCLA parts that have been executed by the software update manager. So that is the information which XCLAs have been executed and what is the runtime. And now you start a tool that supports you in selecting those XCLAs that are able to be moved to uptime processing. And this tool is the software update manager SUM toolbox, which meanwhile collects lots of parts that support you, especially also for downtime optimized conversion. There's an entry, not really visible here, selection of uptime XCLAs. So it's a tool that you run on the target system. After the conversion, your system is an S/4HANA system. And and you run the selection of uptime XCLAs as part of the SUM toolbox, you provide this metadata file, and this tool will tell you which XCLAs are possible to be moved to uptime process. So if it's worth to move it to uptime process, you want to move to uptime. And hopefully my internet connection is stable. And with this tool, you write a file, and this file will be provided to the next run. So then you do a downtime optimized conversion run where you provide this metadata file that includes the selected XCLAs. And if you provide this to the software update manager, you simply put it to the download basket, and then software update manager does know which XCLAs to move to uptime processing. That's the general idea. It's explained in detail in this SAP note, especially for targeting SAP S/4HANA 2020. There are some corrections that are not relevant for higher S/4HANA target releases. And concerning the SUM toolbox implementation, there is this entry note, the central explanation on all those tools that are part of the SUM toolbox. That is a side remark. Additional downtime reduction possible to move long-running XCLAs from downtime to uptime processing for system conversion. Now the small printing comes. Why should you thoroughly think whether it's worth the effort? Well, there are some aspects to be considered. They are listed in a simple list here. Let's have a look. Downtime optimized conversion is an approach that you will use for your conversion of your productive system, as their downtime is typically critical. For other systems, you may say, well, downtime is not that critical, so I use the standard approach. That means there is a mix. Some systems will be using the standard approach. For other systems, especially productive systems, you will use downtime optimized conversion. Then, before you run the downtime optimized conversion on the productive system, you have to run a standard conversion run first to set up the fin customizing. This is explained on the next slide. We'll cover this in a minute. The software update manager has to consider the end user activity. This is done by triggers. So on specific tables that are undergoing the data conversion, the software update manager will set triggers. And in the uptime phase, based on those trigger activities, there's replication ongoing. So additional processes are running that creating load on the productive system. So you need a test run to see whether this load is not disturbing your end users on the productive system while this is still in uptime processing. We have this replication of end user changes. During this replication phase, where the tool will anyhow create load on the system, you have to avoid mass changes or mass activities on the system. Because any mass activities, changing database entries, will result in additional replication activities. So you should avoid archiving. These are some examples where you have to thoroughly plan together with the other areas, the application areas, with the basis consultants to make sure that everyone is aware of those restrictions, that there's no archiving started and you are surprised by this. There are some cases where customizing can't be changed any longer. So that's what we call freeze trigger. Some tables become read-only. So the running of the productive system is affected. You are not free to simply change any customizing, and that will be illustrated on the following slide. And the replication is working on the end user activity. So the question is, how much is the change rate? How high is the change rate by the end user activity? If it's very high on a specific table, you have to see if the tool will be able to really replicate those changes in a reasonable time. So there's more monitoring, more preparation, more test runs. And final part, but an aspect that is widely discussed typically in a project, you should consider a load verification run. That means even before starting the downtime-optimized conversion run on the productive system, we recommend you that you start the procedure as a test run on the productive system, but you just run the procedure until the downtime dialog. You do not enter the downtime. You just use this reset opportunity of the software update manager. But since the uptime phases are passed and the triggers are created, you really see what's happening in your productive system. You see what the replication rate is. So if the tool is capable to replicate the end user changes and what these freeze trigger impact on your system. And this is a lively discussion. Some customers say we will never do this. It's impacting our productive system, and other customers that did this approach have said, of course we have done this. We have to run the downtime optimized conversion anyhow. We would like to see before the actual conversion run whether there's any impact. So now the question, why do I need a standard conversion run prior to the downtime optimized conversion run? This is illustrated here. First, let's focus on this part here. This is to be the downtime optimized conversion run on the productive system. And there you see the illustration that downtime is reduced and there are some activities in uptime like migration and conversion. But if we do data conversion, or if the tool is doing data conversion from the old tables to the new tables, the prerequisite for this is that the fin customizing was already set up on the new data model of the S/4HANA area. That is done here in the what we call the shadow system. So the software update manager will have to set up this fin customizing, but since the tool is a technical tool, the tool does not know how to set up the fin customizing on its own. That is why we first do a copy of the productive system. Then we have a sandbox, that's this block here. And then we execute a standard conversion on the sandbox where the software update manager is only doing the standard activities. And then afterwards, those fin activities are executed. The fin customizing on the new fin data model is executed. And this is put into a customizing request. And we provide this customizing request to the software update manager so that the tool in the uptime can use this fin customizing to set up the fin customizing and to then do the data conversion in the fin area. That in the standard is done by the financial experts. That is the prerequisite. So that is more effort, but it's not created here in the standard conversion run. It's based on a specific setting of the fin customizing of the ECC source system. It's a copy of the productive system. So we copy the productive system to the sandbox. As soon as this is done, we have a soft freeze on the customizing. If during this standard conversion run on the sandbox, anyone would change the customizing on the productive system, we would have a mismatch between the ECC customizing and this fin customizing that is provided based on the old status of the customizing. That's why we have a dependency and a soft freeze. That's not a technical freeze, it's a logical freeze where you have to take care that no changes are done on the productive system, even before you are starting the downtime optimized conversion run. And that's tricky. During the downtime optimized conversion run, there's anyhow a hard freeze, like no transports allowed, no development allowed, but the soft freeze is the customizing freeze. That is in addition there. And again, you have to evaluate whether it's fine for the complete project that those restrictions on customizing on the productive system exist. Now, what does it mean if we have not only a productive system in the landscape? Let's consider this overall customer buffer system dependencies. So the goal is to use downtime optimized conversion on the productive system. Before you start this, of course, you do test runs. That means you have a sandbox, you start a standard conversion. Let's have a look at the legend here. This gray box is a standard conversion run. So on the sandbox, you do a standard conversion run. And once you have done this, you have this fin customizing transport request that is created after the software update manager, reflecting those fin customizing entries for the S/4HANA data model. With this, then you can run this downtime optimized conversion on the sandbox. So you see this box in yellow or orange is a downtime conversion run that requires this fin customizing. This fin customizing request is, of course, also required for the downtime optimized conversion of the productive system. So in this illustration, you may think, well, we have this fin customizing. We just use it for this test run, and we use the same transport for the productive system. But you have to consider that the first test run may be half a year before you start the downtime optimized conversion. So if you would use this fin customizing, you would have a freeze period of half a year. That is probably not what everyone wants. So what you will do is you will iterate those test runs on the sandbox. And then right before you start to convert downtime optimized conversion run on the productive system, you do a fresh copy of the productive system. You have another sandbox and you do again the standard conversion. You again create this fin customizing file to then use this fin customizing in best case first for address rehearsal on downtime optimized conversion, but then specifically for the downtime optimized conversion run for the productive system. So you use a point in time very close to the downtime optimized conversion run for creating this fresh fin customizing that reflects the latest status of customizing in the productive system, instead of using this early one that is months away to be provided here. That's the general idea. And you see, this is higher effort in preparation, in test execution, and especially in the alignment in the project. That's very important that everyone is aware of those restrictions also for customizing. So I would like to finish up with a short overview on the architectural process steps. Again, in the slide deck, the PDF, you will find much more slides that explains the architectural process steps in detail, but I would like rather spend some minutes on potential questions afterwards. So just a glimpse here, and this scenario, this explanation is in this case for the source on non-HANA database. Overall, I guess you have learned downtime optimized conversion can be used either on source system on SAP HANA database, but also on systems on non-SAP HANA database. So this is just a more comprehensive example, since the migration is also part of the game, which in the other case, source already on HANA is not required. Up above, you see those roadmap steps of the software update manager: pre-processing, execution, post-processing. And this illustration here means down below, we have the source system, the ECC system, the source system for the system conversion. It's on the start release on the source database. In this first step, non-HANA. And we have long uptime processing, that's the green block. And then we have a short system downtime. So what's done here on the target HANA database? The software update manager will, as usual, set up the shadow system. So that is consisting of a shadow repository already on the high target level, and the shadow instance, of course, and some customizing is done. Then in the uptime processing, there's a short-term log for asset accounting. It is required to log the asset accounting here to transfer some data to the new data model. So that is another restriction or thing to consider in the project planning. The system is available, it's just that asset accounting is locked for a small period. And then you see this yellow box is decreasing. That means the shadow system has been shut down. Instead, the software update manager will create a similar system that's called the temporary system. There are minor differences that are not relevant now. But in the uptime already, the software update manager will do the initial migration of the relevant tables. What is a relevant table? That's a table that is undergoing the data conversion. So it has to be migrated to HANA first. So from source to HANA database, those tables are migrated. Then they are located in the target HANA database. And then the data conversion is triggered by the software update manager. Data conversion from old to new tables into ACDoc-A, into MatDoc, and the other tables. That's executed in the uptime of the source system. That's what we call the conversion here. I will come back to step number 5 in a minute. It's just step number 4 is initial migration, and step number 6 is the initial data conversion. Since those times here, end users are working on the system, it's green, it's available. So we have to consider delta. That means there will be a delta migration of the affected tables in uptime. And then there's the downtime dialog. We decide to enter the downtime. In the downtime, the final migration of those relevant tables happens. Then all the relevant tables that are undergoing a data conversion are part of the HANA database. So the data conversion can do all the data conversion. It's just that there are some other tables that are not going under data conversion. They have to be migrated as well. That's done here in downtime. Some close-up activities, and then the system is up again running on HANA database. SAP S/4HANA is running on HANA database. That's the general approach. The main information, as said before, migration and data conversion is partially executed in uptime, even with some data, and partially the remaining parts are done in downtime. So I promised you I'll come back on number 5. After the initial migration, you see database tables are migrated here for quite a while, but the data conversion has to work on a consistent set of data. Could be that in this time there was a new transaction created by the user, but those data are only partially migrated to HANA. So not all the relevant database entries are transferred to HANA database, and the data conversion only works on those consistent set. That's why the tool will discard those incomplete database changes that will be done later. That's why we have a revert to snapshot part here. So it's not a database snapshot or something. It's just that only consistent data where all the entries are in all the relevant tables can be converted to the S/4HANA data model. So that was the architectural picture. In the slide deck, you will find a similar picture for source on HANA database, where of course migration is not relevant and we just have one database. The source database is the target database for the standard conversion and for the downtime optimized conversion run. It's worth mentioning that DMO with system move that allows a transition to a hyperscaler, for example, for a system conversion is not supported together with downtime optimized conversion. Just as a side remark, this is of course reflected in the SAP node on downtime optimized conversion run. And on the very first slide, there was a link to a dedicated SAP page in the SAP support portal where you find all the relevant SAP nodes and latest information. That was what I wanted to tell and show you today on downtime optimized conversion. Overall, it is an approach that can be used by customers and partners, assuming that they have an educated expert that has done the training to really know about all the details on freeze triggers and requirements. And it is possible to reduce the downtime of a system conversion. It has higher effort and more things to be considered in the project planning. Thank you, and let's have a look if we have questions in the chat.
Thank you, Boris, for your presentation, for these detailed instructions on how to run a conversion. And yes, we have questions in the chat, and I start with the first one. So the recommendation is to simulate S/4HANA conversion up to downtime, then undo the pre-processing, then weeks later redo the S/4HANA conversion.
Yes, maybe I jump back to the slide where this was mentioned, what we call the load verification. I do not have a dedicated slide on this, but on this slide, we see the load verification. So the recommendation, just to repeat what you have said, what was written, the recommendation is after all the preparation has been done, you start the software update manager on the productive system with a downtime optimized conversion approach, and you run the sum tool on the productive system until the downtime dialog to see what the freeze trigger has an impact and what the end user activity is on the system. And then you can reset the procedure so that the sum procedure will restore everything. The system will, of course, continue to run. There's no impact. And then 1 or 2 or 4 weeks later, you start the actual downtime optimized conversion run on the productive system where you execute the downtime. As an additional remark, of course, you may also consider you start the downtime optimized conversion run on the productive system until the downtime. You see the potential impact of freeze and replication rate. You do not reset the run, you just keep it running for maybe a week, and then you enter the downtime. That's possible as well. It's just, this is additional time waiting for 1 week where those freeze triggers are impacting the system and no transports are allowed. But it's possible in theory as well. So I hope I have answered the question in a helpful manner.
There is a follow-up question to what you've just said. Is it a hard freeze on FI customizing or all customizing, meaning SD, MM, FI, and so on?
Yeah, that is a good part. I have a good question. I've just said there are restrictions on the customizing, and this is to be clarified in the project as well. There is a dedicated list of what is allowed, what is not allowed in the customizing area that is part of the guide for downtime optimized conversion. So where do you find those information? There is a landing page for the software logistics toolset. It's the SL toolset page. Let me expand this. And there is a dedicated section on system maintenance. If you scroll down, you see system conversion. And there on the system conversion page, you see the downtime optimized conversion approach with the actual node, with a guide. And this guide here contains those customizing informations. So I said customizing is frozen, but there are specific lists what's allowed and what's not allowed. So that's part of the guide. And with this, I can also advertise the separate support portal page on downtime optimized conversion that I've already mentioned. Let's open this in a separate browser window here. Downtime optimized conversion. It's the same introduction with a similar picture as we have seen, and relevant project planning aspects that are especially also to be considered by the non-technical colleagues there, like mass load activities are forbidden. Here's the training that is required and relevant sources of information, the respective guide and the SAP notes. Thank you.
Boris, can you place the link to this page in the chat so I can share it with the community?
Yeah.
So
this
the next
page, sorry, this page is mentioned on the very first slide, but nevertheless, I have pasted it in our chat so you can provide it.
Exactly, for the convenience of the viewers.
Yeah.
So the next question is, there is a possibility to record the simulation of S/4HANA conversion until the stop time, then run the safe scenario in the real project.
I think I did not fully get the point. To record, not sure.
There is a possibility to record the simulation of S/4HANA conversion until the stop time, then run the safe scenario in the real project. I think it's a question regarding the steps.
Yeah, I'm not aware of a simulation and safe mode. So, so from what I understand, I would say that is not possible.
Okay, if maybe the author of this post can provide some details, and I move on to the next question. I have a question about support package freeze during S/4HANA project. Here in Canada, we are mandated by law to apply HR support packages once a year. We find it extremely difficult to combine HR support package application in the middle S/4HANA conversion project. Any recommendations? Question mark. Our Canadian customers keep saying that SAP must have a solution.
I understand that this is a tricky solution, but I do not have an easy answer at hand for that. I'm sorry. Yeah.
Can we take this question for a follow-up, or do you think it's okay?
Yep.
Then we try to provide any ideas either in the description to this video or in the next session. So then the next question is: downtime-optimized conversion requires an additional license or fees?
Yeah, good question. There are no additional fees. There is no specific license required, but it can only be executed by an educated expert. That means there is effort and costs to take this 2 days training class and to pass the assessment batch. So it's not a license, it's not an additional cost for the approach as such, it's just for the education, which is mentioned here on the training class. That is a 2 days training class.
Okay. Then the next is, so in your project view, the load verification run has to be started after the dress rehearsal, or where does it best fit in?
Yeah. So this picture here says you have several sandbox runs where you create this fin customizing request in a standard run to be provided to the downtime optimized conversion run. And now in here, we recommend to have a dress rehearsal as well on the same environment like the productive system. And there you use exactly the same conditions, boundaries, and this fin customizing. So that is what we say as a dress rehearsal to be executed right before the actual downtime optimized conversion run on the productive system is running. Hopefully that was fitting to the question. Otherwise, let me know.
Okay, the next question. So for DMO with system move, the best way to reduce downtime is parallel transfer mode. All other options not applicable, right?
Correct. I only shortly mentioned this here. DMO with system move is an approach where the tool will not only do the migration for the database, but also allow to transition to a different application server environment, especially to hyperscaler. This DMO with system move does not allow to use downtime optimized DMO or downtime optimized conversion. I did not mention in this session that we have currently a pilot project ongoing to evaluate a different approach, especially for the transition to hyperscalers combined with a conversion. We evaluate a simplified approach compared to DMO with system move, but this is not yet available and we cannot yet say when this may be the case.
Okay, thank you. There is some clarification to the previous question regarding the load verification. Actually, the question was where the load verification run on PRD fits into the project view.
Okay, yeah, now I got it. That would be in between here. No? I would say after the dress rehearsal, or maybe before the dress rehearsal. That's the area where you would do the load verification run there.
Okay, I hope this clarifies the question. So I've also placed the link to the SAP support page dedicated to conversion tools. So for those who are in the session, you can go directly there and get the information, in more detailed information on what Boris just mentioned. And of course, as promised, the PDF of this session will be available in the description to this video shortly after the call. Okay, I see. Thanks. Thanks from those who have stated their questions. I probably ask Toto to share how we can reach out to you in case of follow-up on this HR package in Canada. So it would be good to know how to connect with you. So I can't see additional questions in the chat. Again, thank you, Boris, for your presentation. It brought a lot of value and interaction with the viewers. And of course, thank you to all our viewers for being so attentive and bringing up questions. With this, I would like to finish the session today. Tomorrow we will have the next session by Boris, and we hope to have you in our stream again. And yes, and of course, we would like to welcome you in one of our upcoming sessions. And so stay tuned with us with this. Thank you very much and have a nice day.
Bye.